Hello friends, now in vector calculus we take another topic named as divergence and curl of a vector function. Now we know that a vector is a quantity that has a magnitude in a certain direction, and we know that vectors are used to model forces, velocities, pressure, and many other physical phenomena. Now, a definition of vector field. So, a vector field is a function that assigns a vector to every point in space. See, we know that a real valued function is what? So, it assigns a real number to every point, say y equal to fx. So, similarly, here it assigns a vector to every point in the domain. So, vector fields are used to model force fields. So, in force fields, there are gravity, some electric field, and magnetic fields, then fluid flow, and so on. Now, one concept is divergence. So, first of all, let us see what divergence means, even in its linguistic way also. So, divergence is an operation on a vector field that tells us how the field behaves towards or away from a point. Now, locally means at a point. The divergence of a vector field f at a particular point P is a measure of the outflowingness of the vector field at P. Say if f represents the velocity of a fluid, then what is the meaning of its divergence at some point P? So, it is nothing but a net rate of change with respect to time of the amount of fluid flowing away from P. So, imagine that the vector field pictured below gives the velocity of some fluid flow. It appears that the fluid is exploding outward, so going outside from the origin. So, the divergence of the above vector field is positive because it going outside. The flow is expanding. So, this is a outward going outside. So, the value of the divergence is here positive. And in contrast, the vector field represents fluid flowing so that it compresses as it moves towards the origin. So, coming inside. So, since this compression of fluid is the opposite of expansion, so the divergence of this vector field is negative. Now, let us formally define the divergence, how to find out the divergence. So, before that, let us first recall our semester 1. We defined there the operator del. So, that is a del operator, and that we know that is I del by del x plus j del by del y plus k del by del z. Again, we also know that the gradient of a scalar point function means the function whose value is scalar. So, this also we know, we write like this, it is grade f, say f is a scalar point function, then grade f is, we write this way, del f, that means I delta f by delta x partial derivative plus j del f by del y plus k del f by del z. This is gradient of f. We know that it represents the outward normal to the surface f. Now we define formally the divergence. So divergence of a vector point function. So let this f is a vector point function. F is a vector point function, and divergence of f we write this way also, divergence f, and it's defined like this. It's a dot product with operator del. So del dot f. So we can now see that the divergence of a vector point function, because it's a dot product, so note that divergence of a vector field is not a vector field, okay, it's a scalar function. Now let us see how to find out the divergence when you are given some function f. So say suppose you are given the vector point function f, so it is like, say, we can write like f1i plus f2j plus f3k, like this. So divergence of f equal to, this is the formula, del dot f. So it's a dot product between this del operator. So we know I del by del x plus j del by del y plus k del by del z, and its dot product with f1i plus f2j plus f3k. And so this is nothing but del by del x of first component f1 plus del by del y of second component, so f2, and del by del z of third component, so f3. So this is the way you can find out the divergence of a vector point function. Let us solve one example. So find the divergence of say f equal to x square z I minus 2 y cube z square j plus x y square z k, say at some point, say at the point say p 1 minus 1 1. So now see, the f function is x square z I minus 2 y cube z square j plus xy square z k. And see, this is nothing but like f1i plus f2j plus f3k, where this f1 is x square z, f2 is minus 2y cube z square, and this f3 is xy square z. So now divergence means just take the first component f1, take its derivative with respect to x, then f2 derivative with respect to y, it's a partial derivative. This is f3 and take the derivative with respect to z. There is no in between I, j, k. So divergence f So that is the definition. Del dot f equal to del by del x of first component, so that is x square z, plus del by del y of second component, so it is minus 2y cube z square, plus del by del z of third component, so x y square z. And it is easy now with partial derivative with respect to x, so this is 2x z, then partial derivative with respect to y, so it is minus 6 y square z square, and this partial derivative with respect to z, so it is x y square. So this is divergence of f, and we want to find divergence of f at certain point. So divergence of f at the point 1 minus 1 1. So just plug in the value x as 1, y as minus 1, z as 1. So 2 1, z is 1, minus 6 y square, so minus 1 square, this is 1 square, plus x is 1 y square, so minus 1 square, and you can just simplify. So this is the divergence, so minus 3. So here you can say that for this function divergence is negative, so the flow is coming inside. I am just giving you one more example as homework. Find the divergence of, say, f equal to x y z I plus 3x square y j plus xz square minus y square z k. Here point is not given, so up to this is your divergence if point is not given. One more example if you want. It's simple partial derivative only. Find the divergence of, say, f equal to xyz into xi plus yj plus zk. So here you should take xyz inside, like the f1 function is x square yz, f2 is x y square z, and f3 is x y z square. Okay, now sometimes it happens that the divergence of a function is 0. That means the flow divergence of the flow is not going out, not coming inside. So that kind of vector is known as solenoidal vector. So let us just define. So if divergence of f is 0, then vector f is called a solenoidal vector. Take care, this 0 is a scalar. Now we define the another concept, that is curl of a vector point function. The second operation on vector field that we examine is the curl. Now the curl measures the extent of rotation of the field about a point. That is the physical interpretation. So suppose that vector function f represents the velocity field of fluid. Then the curl of f at a point P is a vector that measures the tendency of particles near P to rotate about the axis that points in the direction of this vector. And the magnitude of the curl measures how quickly the particles rotate around this axis. So, in other words, the curl at a point is a measure of the vector field's spin at that point. So, this figure is visualizing this. So, imagine placing a pendule wheel into a fluid P with the axis of the pendule wheel aligned with the curl vector. The curl measures the tendency of the pedal wheel to rotate. So, this is the way the curl is understood. But we define formally mathematically the definition of curl. So, curl of a vector point function so let f be a vector point function. Of course, it's a differentiable. Even in divergence also the function f should be differentiable. So this should be differentiable. The curl of f is defined as like this: curl of f equal to del cross f. So it's a cross product. So this is a vector quantity. So curl of a vector point function is a vector point function. How to find the curl? Let us see that part. So if you are given a function like this, say f1i plus f2j plus f3k, then curl of f is del cross f, and so we can find the determinant like this: I, j, k. Now del operator, so it is del by del x, del by del y, del by del z, and f, so f1, f2, f3. This is the way we can find the curl of a vector point function. Let us solve one example. So let us find the curl of a, say let us take one simple example first. So find curl f of the function f x square y I minus 2xz j plus 2yz k, and at say say 1 0 2. If point is not given, you can just write without that. So curl f, so the it is I, j, k, then del by del x, del by del by y, and del by del z, and the function f. So first component is x square y, then second component is minus 2xz, third component is 2yz, and we have to just evaluate this determinant. So this is I. So now del by del y of 2yz you can write directly also, then minus, already minus sign is there, so plus del by del z of 2xz, okay, then minus j del by del x of 2yz and minus del by del z of x square y, then plus k del by del x of minus 2xz and minus del by del y of x square y. This is just simple the way we are evaluating the determinant. So this is I. Now del by del y of 2yz, so that is 2z, del by del z of 2xz, so that is 2x, then minus j del by del x of 2yz is 0 and del by del z of x square y, so that is also 0, plus k del by del x of minus 2xz, so that is minus 2z and minus del by del y of x square y, so that is minus x square. And now this is curl f, and you want curl f at some point, say 102. So we put x is 1, y is 0 and z is 2. So this is I, x is 1, z is 2, so 2 to the 4 plus 2, so that is 6, plus this is 0 j, z is 2, so that is minus 4, x is 1, so minus 4 minus 1, so minus 5k. So this is curl of a function at some point. Okay, I give one or two example to you to find out the curl in this way. So let us write. Find curl of f at the point p1 minus 1 1 where f is 2 x square y z I minus x z cube j plus 2 y z power 4 k. So same way you can find out. Now just like the solenoidal vector where divergence of the function is 0, here also if the curl of the function is a 0 vector, then it is called an irrotational vector. So if curl of f is a 0 vector, then this vector f is called an irrotational vector. So let us solve some example. Find divergence of say gxyz, that's a vector point function, e power x I plus log of xyj plus e power xyz k. So divergence of g is del dot g. G is a vector function, okay, and this is like f1, f2, f3. So divergence of g is like I del by del x of first component, so it is e power x. Do take care, here divergence is not having I, so that is a mistake, okay, it's a scalar function. So del by del x of e power x plus del by del y of second component log of xy plus del by del z of third component, that is e power xyz, and del by del x of e power x is e power x, del by del y of log of xy, so it is 1 over xy, and derivative of xy with respect to y is x, plus del by del z of e power xyz, so that is e power xyz, and derivative of xyz with respect to z is xy. So divergence is e power x plus 1 over y plus xy into e power xyz, that's all. Now let us take one more example. If phi of xyz equal to xyz minus 2y square z plus x square z square. The question is find divergence of grade phi at the point P 2, 4, 1. Now see, here phi is not a vector function, but you are not asked to find out the divergence of phi, you are asked to find divergence of grade phi. So first we need to find the gradient of phi, and then we can find its divergence. So phi is like this, xyz, this is xyz minus 2y square z plus x square z square. So first we find gradient of phi. So gradient of phi is del phi, and that is nothing but vector I del phi by del x plus j del phi by del y plus k del phi by del z. Take care, I here del phi by del x, so the derivative of this phi with respect to x, and so that is yz plus 2x z square plus j derivative of phi with respect to y, so this is xz minus 4yz plus k derivative of phi with respect to z, so that is xy minus 2y square plus 4 x square z. This is our gradient of phi, and this will become this is wrong, this is 2x square z, sorry. Now this is our f1, this is our f2, and this is our F3 for finding its divergence. So divergence of gradient of phi equal to, now there is no I, j, k, divergence is a scalar function, derivative of first component with respect to x, so only first component, and in gradient derivative of the whole function, there is no such component. So yz plus 2xz square plus del by del y of xz minus 4yz plus del by del z of xy minus 2y square plus 2x square z. So derivative with respect to x here, so this is 2z square, derivative with respect to y minus 4z, derivative with respect to z, so plus 2x square. So this is divergence of gradient of phi. Now we want divergence of gradient of phi at some point, at the point 2, 4, 1. So that you can find. Okay, I leave to you. Take one example. Find curl of f where f equal to gradient of x cube plus y cube plus z cube minus 3xyz. This was asked in GTU 17. So first we find gradient. So we call this function, suppose say phi. So let us first find gradient of phi. So that is I del phi by del x plus j del phi by del y plus k del phi by del z. So that is I, the derivative of this function with respect to x. So that is 3x square minus 3yz plus j, derivative with respect to y. So that is 3y square minus 3xz and plus k, derivative with respect to z. So this is 3z square minus 3xy. So this is our f. This is our f, and we want to find out its curl. So curl f equal to I say j k del by del x del by del y del by del z, then this is 3x square minus 3yz first component plus this is 3y square minus 3xz, this is 3z square minus 3xy, and so this is equal to I. Now del by del y of 3z square minus 3xy minus del by del z of 3y square minus 3xz, then minus j del by del x of 3z square minus 3xy minus del by del z of 3x square minus 3yz plus k del by del x of 3y square minus 3xz minus del by del y of 3x square minus 3yz. And I think I can give to you this to complete it, so it's not difficult. Okay, we take some more examples. Let us take one example. So that the vector f y square minus z square plus 3yz minus 2xi plus 3xz plus 2xyj plus 3xy minus 2xz plus 2zk is both solenoidal and irrotational. This example was asked at least 5 times. So now we know solenoidal means divergence of that function is 0. Irrotational means curl of that function is a 0 vector. So for this f we need to find its divergence, and for the same vector we need to find its curl. So let us find first the divergence. So divergence of f is, it's a scalar point function, there is no ijk, del by del x of first component, so del by del x of y square minus z square plus 3yz minus 2x plus del by del y of second component 3xz plus 2xy plus del by del z of third component 3xy minus 2xz plus 2z, and then find its derivatives. So del by del x here is 3y, sorry, no, only minus 2 plus del by del y, so this is 2x plus del by del z, so minus 2x and plus 2, and we see that this is 0. So f is, vector f is solenoidal. Okay, we want to prove it is irrotational also, so we need to find out its curl. So curl of the function f, so this is I j k, then del by del x, del by del y, del by del z. So first component is y square minus z square then plus 3yz minus 2x. Then second component is 3xz plus 2xy. And the third component is 3xy minus 2xz plus 2z. So let us evaluate this determinant. So this is I, and then del by del y of 3xy minus 2xz plus 2z minus del by del z of 3xz plus 2xy minus j del by del x of 3xy minus 2xz plus 2z, then minus del by del z of y square minus z square plus 3yz minus 2x plus k del by del x of 3xz plus 2xy minus del by del y of y square minus z square plus 3yz minus 2x. So this is I. Now del by del y of 3xy minus 2xz plus 2z, so that is only 3x. Then minus del by del z of this 3xz plus 2xy, so that is 3x. Then minus j del by del x of 3xy minus 2xz plus 2z, so that is 3y minus 2z minus del by del z of y square minus z square plus 3yz minus 2x, so that is a minus sign and again right bracket, so that is minus 2z plus 3y plus k del by del x of 3xz plus 2xy, so that is 3z plus 2y, and minus del by del y of y square minus z square plus 3yz minus 2x, so that is 2y plus right bracket here plus 3z, and we can see that this cancel. So same term plus minus sign. So this is 0I plus 0j plus 0k, and so it is 0 vector. So curl of f is a 0 vector, and therefore f is vector f is an irrotational vector. Let us take one more example. find constants A, B and C such that vector V, this is x plus 2y plus AZI plus BX minus 3y minus ZJ plus 4x plus CY plus 2Z K is irrotational. So we know that the vector irrotational, then its curl is a 0 vector. So given vector V is irrotational and therefore its curl is a 0 vector, and therefore I J K, then del by del x, del by del y, del by del z, then this is x plus 2y plus AZ, then here it is BX minus 3y minus z, then this is 4x plus CY plus 2z, and this determinant should be a 0 vector. So therefore this is I into like this del by del y of 4x plus CY plus 2z minus del by del z of Bx minus 3y minus z, then minus j del by del x of 4x plus CY plus 2z minus del by del z of x plus 2y plus AZ, then plus k del by del y of x plus 2y plus AZ minus, okay, there is a mistake, sorry, so plus k del by del x of Bx minus 3y minus z minus del by del y of x plus 2y plus AZ, and that is equal to 0 vector, that means 0I plus 0j plus 0k. So therefore I del by del y of 4x plus cy plus 2z, so that is c here, then del by del z of bx minus 3y minus z, so that is what, minus, and the derivative is minus 1, so this is minus minus plus, then minus j derivative of 4x plus cy plus 2z with respect to x is 4, minus derivative here is with respect to z, x plus 2y plus az, so that derivative is a, minus sign, so minus a, then plus k, this derivative with respect to x, so that is b, and minus derivative of x plus 2y plus az with respect to y is minus, and this is 2, and this is 0 vector, so 0 vector is 0I plus 0j plus 0k. So you can just compare the component. So therefore c plus 1 equal to 0, then minus of 4 minus a equal to 0 and b minus 2 equal to 0. So therefore c equal to minus 1, a equal to 4 and b equal to 2. Thank you.